Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
Hey, Kirk. I understand you got just before we got started, you were searching the news for topics to talk about today. So
Right.
Any hot topics that mention your name and reference your great work over the years? Like that? Or...
No. But
I
will mention that I've updated my website, acceleratedreliabilitysolutions.com, and added some of the articles and some of our podcasts listed, along with other articles that I think are helpful to question some of traditional electronics reliability approaches and some of the things that I've posted on Accendo Reliability also.
Cool.
But yeah, I was looking at, I kind of do searches, and I put in keywords for notification from Google or Google searches. It'll send me every day anything to do with reliability. And also, but then I go in and sometimes do a Google search, or with the Google News, I go to the technology section and just put in electronics reliability. And here's an interesting article from 2021 called from Hot Rod Magazine. And it says, starting line, do automotive electronics stand the test of time? And I thought, well, I haven't really read it, but it does talk about, some of these electronic modules have been in, decades. 20s when he says is in his 1993 GMC is 28 years old. And it said
the 1920 or the 1993 GMC had what? 3 circuit boards total, counting the radio?
Yeah, and sure it's got, but at the same time, they've also gotten fewer components probably, right? I mean, they've more integrated boxes, or maybe higher level control chips, modules that are in a smaller package. I mean, just like all electronics.
Well, I think for every example you bring up of how long it's last, I can probably counter with, and this controller in I think it was a Chevrolet vehicle, failed after 5,000 miles. And this entertainment system that required the removal of the entire dashboard to replace it, got recalled because the electronics was doing something weird and it would interfere with other parts of the vehicle. And so there are plenty of examples of electronics that go bad.
Right. And how many of these do you think were due to intrinsic failure mechanisms?
I don't care. It failed.
I know you don't care.
I don't care if it's intrinsic or not. It failed.
All the reliability engineers are focused on.
No, I'm not.
You're not. There's a few of us that aren't. Okay.
If it fails, it fails.
It fails.
If it's manufactured bad, if it was damaged, if it was poorly designed, if it was just they swapped out the wrong components at the last minute just to ship it, those are still failures. Kirk.
And those are probably what caused the failure.
That's probably. I don't care. I still had to take it to the shop. I still had to get my car. The first one was the car was dead on the side of the road. I couldn't even start it.
Right. And that just, again, demonstrates how much more painful an early life failure, or somewhere after trusting it in it failing, is very frustrating.
Well, going back to the hot rod deal, is like, do they stand the test of time? The ones that survive the first couple of years do. They're probably just fine. They'll keep on going until they're
They've
obsolete.
got plenty of life in them. They've got lots of life. In fact, they may go way, just like I say, in my pinball machine, I've got chips from even earlier than this, 1983, and it's still working fine. They're not, and I don't think they're going to wear out.
No,
but I don't.
But there's other things that it still matters, and I think part of an article like this that says, this stuff lasts forever, and you talking about intrinsically, if the electronics, a laptop can go at high temperatures for a long, long time. It's just fine. The issue is that the too many reliability engineers and way too many managers say, oh, we'll put it in a chamber and see if it works. It should work for 5, 10 years and then we're good. And totally ignore that. Well, you got to have good components, good design, good manufacturing, good transportation, and hit your customer with a product that fits their use. If they're going to put an inkjet printer for home use on a fishing boat, and it's going to rust out in about 2 minutes. Well, maybe 2 months. But the idea is that a lot of other things count as reliability than just it works a long time.
Well, you just mentioned all those things, but they also have to stay the same in time. Every unit has to be manufactured identically the same, and that just
That's not going to
over
happen.
time, that's not going to happen. And the amount of variation, yeah, we all use, the big thing was SPC a few
Still
decades
is.
ago, still
Still
is.
is.
But a lot of them I've seen, back in the old days, it was just wallpaper for a lot
Yeah,
of
yeah. A lot of
companies.
them were pretty useless in factories, but
So, but yeah, that's, manufacturing consistency is something that is critical. And you can't always, in this long chain of manufacturing of suppliers, from the epoxy, the wireframes for the chip, everything.
encapsulants, yeah.
Yeah, all of it is at any point somebody could uh, lose control, and it results in a latent defect that you're not going to know about, and until it manifests itself in either a stress condition or over time, which is the same, the fatigue damage occurs, or chemical reaction occurs over time. So
Yeah.
all those are the bigger factors. The big factors cause the vast majority of failures in my assessment and my understanding of it.
Well, there's also, and Chris is going to talk about it next week in a webinar, is that any kind of maintenance action often causes damage. So if you're changing the oil and you happen to
Exactly.
hit that engine controller
Exactly.
module and pour oil on it, then
Exactly.
the world is not kind in vehicles. And the
Right.
other thing I saw, and we didn't, you mentioned the title of this article and immediately made me think of, I saw a graph, well, it was years ago, of the amount of electronics just inserted into vehicles. It used to be your radio. That was it.
Mm-hmm.
Right. Now, I mean, they've
It's
got
your backup
sensors.
camera, your sensors.
Well, they
Well,
got stuff checking your tires to see if they got the right
right.
air pressure
Exactly.
and
Exactly. Which is
on and
great.
on and on. And
I love that. You get to know you're going to have a flat before you have a flat.
yeah, but there's great features out there, right? But the amount of electronics being embedded into vehicles it was the trajectory was that the cost of the design and manufacturing, or the cost of goods sold, used to be just steel, right? It
Yeah.
is all the steel that goes into your vehicle. Now it's
Right.
not even steel anymore, half your vehicle, but it's the cost of the electronics is outpacing the cost of anything else in the vehicle. It's more expensive by far than the motor train, the engine,
Especially
and
in EVs.
yeah,
In fact, they're getting bad ratings from the fact that they're not as reliable, from
yeah.
the fact that they have so many electronic systems, and it's basically depending on that. Totally, there's no, I see these ads for that are narrated, that the car engine shows it dropping off all these parts, and it says, you get rid of spark plugs, you get rid of oil, you get all these things, but they don't really talk about the fact that, you're also going to have so many more electronic connections and interfaces. And I've seen it reported in Consumer Reports that some of these well-known EV manufacturers have had very big reliability issues.
Oh yeah, and it's back to what we started with. It's not necessarily it's bad electronics. It's in the wrong application. You just don't take a laptop and screw it onto your dashboard and hope for the best. It's a different environment. Than just the vibration alone is going to be crazy.
Well, laptops in general have to be able to withstand a reasonable amount of shock and variation in their environments because they really are go anywhere. And you know, what I when I tested laptops, it was really hard to break them. I mean, it was
Yep.
really hard to. I'd crank up the Halt chamber to full volume. You know, when I had a solid state disk drive in there,
Yeah, to
I couldn't.
suspend it off. Yeah.
Well, no, I didn't know if I took away the disk drive,
Yeah.
okay, put in a solid state, which has no problem with vibration,
Yeah.
and I couldn't get it to burp at
Right.
40 G's RMS.
Yeah. And it's a laptop that works. Is because
Yeah.
you weren't going to put in a laptop that had boot up issues or started smoking when you
No, no,
fired it
no,
up or
no,
anything
no,
else.
no.
So you get through the infant mortality type stuff and then you're
Right.
fine.
Right.
Generally.
Generally, right. There can be long-term latent defects that are, you know, stretch out for anyone that's
Insufficient solder
early
is the
has
classic
a
one.
yeah, it's a distribution, you know. Some, if they're in a mild environment, may never manifest themselves as
Yep.
failure. Others in a very harsh environment, but still have a fairly good bond, may still get broken. So
Yep.
you never know where that strength and stress crossover is in the distribution, but it does happen. So, but I just think, you know, I think engine motor modules and things that are under the hood of a car, and considering where cars are driven and where they exist in basically every part of the world, where I don't know the Antarctica, I guess not.
Yeah, yeah. There's vehicles there.
Yeah, okay. So, you know, even so thick that, I mean, so cold that the diesel fuel it turns into gel. But, you know, they just have to go through these huge, are a very wide distribution of end-use environments and end-use conditions.
Well, that's an engineering challenge. That's not a
Yeah.
reliability challenge.
Well, it's an engineering challenge to survive all the
Hmm.
damage and fatigue and stress that those modules will go through their entire life and what they're designed life for. At the same time, I think a lot of car manufacturers have extended their warranties. I know 3 years is kind of common. Some is as long as 10 years, I think.
Yeah.
I don't know what it is today because I'm not buying a car or shopping for one.
See, you're bad for the economy then. I saw an article
Well,
the other.
well, because they're reliable. I would buy a car, and I do wish that as soon as really autonomous driving vehicles come about and are generally, you know, proven fairly well, other than the, you know, Waymos on the street and everything, that will be something that I definitely will want as I age out,
Oh
as I
yeah,
get creaky and my eyes start to fail.
yeah,
I
yeah.
do
Then
want to.
it would be a
I do
godsend.
want.
Then it'd be really cool.
I know independence, you know, to be to move about and to go places without another human is something we all really enjoy, being able to just drive away. So hopefully it'll be, and I think it will be in another 10 years that we'll see better,
I can,
safer.
I can see a drone coming over your house, and you get your wheelchair outside, and it hooks you up and
Yeah,
flies
it
you
picks,
to wherever
yeah,
you got to go.
locks me. I don't want to go that high. I just I'm a land hugger. So
Yeah, but I mean, there's a couple issues with the electronics. It's still a learning curve. We're adding so much electronics and features into systems, and the autonomous vehicles then have really no tolerance. If you lose the right side cameras, your car's going to stop. It's because they can't see where traffic is or if people are there or anything,
well, yeah, if you're in
right?
this autonomous, right, those are
Right.
going to be and communication between cars is going to be critical too, because
Yeah.
they're all going to be talking to each other.
Right. But the idea is that the the more dependence on the electronics, the less able that vehicle is going to tolerate a single failure, right? Unless it's designed to be totally redundant and those critical aspects of the system, driving the costs and the electronics up in the system.
Right, right.
The other issues is that just because you designed a laptop doesn't mean you can design a motor controller or brake system electronics in a vehicle. Completely different environment. The concepts in electronics is the same, but
Right.
you're going to end up spending more money on encapsulating this thing, protecting it, environmentally sound, heat management's different. All kinds of things are different. And it takes time
Mm-hmm.
and expertise. And I know that with all the different startups from Tesla to Rivian and all the big manufacturers are sucking up all the talent to be able to do this stuff. So
I
it's
Yeah, but at the same time, Fred, I don't think that it's incredibly more expensive to build a robust reliability electronic module. In fact, they're becoming encapsulated. Just like look at the smartphones. They're nearly a brick. There's hardly
mhm.
any air space in those things.
Yeah.
It's becoming almost a solid brick, and that lends itself to making a much more reliable uh, product. Is just nothing can move.
Yeah, but see former episodes where we talk about our daughters and their ability to break
Yeah, to break
this
phones.
brick phones.
Yeah. Well, that was the glass. That was mostly the glass. So the electronics underneath, I rarely saw that fail. I saw the glass fail, but the touch screens and the physical buttons might fail over time. But again, I always try to emphasize the intrinsic life of most electronic solid state electronics is much longer than the technological obsolescence. So that again, I'll buy a new car not because anything's worn out about mine, because I do. There are mechanical things you have to always deal with: oil change, tires, um, even alternator,
Windshield
maybe spark
wipers.
plugs, windshield wipers, and things like that that are physical, mechanical things that wear.
Wait a second. How old is your car? You have spark plugs? You do
Yeah,
need a new car.
exactly, exactly.
All
But
right. But
the
there's this.
there's all kinds of technological improvements like rear, parking, and you've got, the backing cameras and now sensors around the car to tell you that you're close to something,
Yep,
and it lets you know. And pretty soon, of course, they'll be totally a not, well, they're getting closer and
getting
closer
closer, but we were promised this 10
to
years ago.
commercially available for the consumer, because they are definitely. Waymo is all over the place in lots of cities,
Yep.
and so they're gonna get there. And just like anything, I had professors say, "Oh, that'll never happen," and I thought, "What kind of guy is this? Is not an engineering professor, because that's just
It's just
most
bait for those
engineers say, 'Hold
engineers.
my beer, and I'll show you, and just give me another 5 years, and we'll have one,'
Yeah.
and they did, and that's so." But I think, again, the real problems in reliability of electronic hardware is consistency of manufacturing, design margin, and understanding the variation in manufacturing locations and also use environments.
Yeah.
And building it again, I always say build it as strong as it can be with standard materials and methods. And that can be pretty strong. If you go
Well,
test
it can be, and I
lots
agree
of
with you.
circuit boards, you'll find that you can't break them in a thermal chamber.
Yeah.
You
No,
can cause them to fail, but
well, you can,
they'll
but
come back and recover.
I totally agree with it, and we'll sum it up on that. Is
Okay.
that yeah, there are issues, but the title of this article was over the long term, and it's like they're ignoring the front end, getting all the parts that we know really do cause the problems with vehicle electronics. So buyer
Yeah.
beware on all that good stuff. Make sure you run through a complete diagnostic of all of your electronics and put it in a halt chamber for 3 days and see what happens. But I don't think that's going to happen either.
I have a
Yeah,
2012 Honda. Still, I haven't had any electronic problems with it.
it has a ignition switch, and that's about it. A radio.
16 years. I don't know,
Yeah,
15. So anyway, yeah.
but the idea is that it's interesting the focus of the article, and it's often gets associated with reliability. And the point is that if a failure occurs for any reason, it's still a failure. Now, you
Right.
might call it a quality issue. You might defend it off other ways. But if you're listening to this, how do you deal with this? How do you parse out how do you get to the long term so that it isn't an issue at all? How do you make sure that it's got all the rigor that it needs so that you don't have all these built-in latent defects? Or if you got a similar or a different question, or if you saw an article lately, send it on over. Kirk and I take a shot at it and see what we think about it. But let us know. Head over to accendoreliability.com/go/SOR. You can find a couple of ways to get in touch with us. Kirk and I and the other hosts are all available through LinkedIn and our About pages. And Kirk's got an updated website you need to go check out. So I'll give you a shout out on your site.
All right. We'll put a link there to that one.
Right.
So, Fred, go out and have a reliable day.
Yeah, that's a good sign off. You too, Kirk. Enjoy a nice, reliable day.
Okay.
All right. Sounds like a beer ad, doesn't it?
Yeah.
Talk to you later, Kirk.
We'll talk to you soon. Okay.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.